Hello, everybody. Welcome to the server side with Kotlin webinar series. And today we have James Ward from Google here with us talking about all kinds of Kotlin stuff on Google Cloud, right, James?
Yep, that's right. It's great to be here.
Perfect. Before we start, let me do a short overview of what has been happening. So today we have James with running Kotlin on Google Cloud. Last week we had Victor Gama from Confluent talking about Apache Kafka event streaming platform for Kotlin. And in January, we are going to have James Tsang from Google talking about developing backends with Kotlin and Spring for Google Cloud as well. So without further ado, I think we can start with your presentation, James.
Awesome. Thanks, Antoine. Thanks, everybody, for joining us. I'm James Ward. I'm a developer advocate on Google Cloud, and been using Kotlin for almost 2 years now. I come from Java and Scala before that, and been really enjoying Kotlin and been using it to build a lot of stuff on Google Cloud. So that's been a lot of fun. So we're going to dive right in and deploy some applications and walk through some code and build some stuff. And if you have any questions, you can just ask them, and then Antoine will pop in and relay those to me. So feel free to ask those. Okay, so let's dive in. So the one of the best places to get started is on GitHub, on the Google Cloud Platform, and then Kotlin samples repo. And here we have a bunch of sample applications to get you started doing Kotlin on Google Cloud. I'm going to start with one that's in this run directory because we're going to be deploying something on Cloud Run, which we'll learn about in a second. So there's a lot of different samples here, and I'm going to go through a number of these today. But let's start with this GRPC Hello World streaming sample. So I'll walk through the code here in a second, but I want to get this thing deployed in the cloud because it's going to take a couple minutes to deploy it. And so there's this big button here that says run on Google Cloud. So I'm going to click that button, and this is going to take me into what's called Cloud Shell. And I'm going to say, yep, I am sure that I want to deploy that repo. Cloud Shell is just like an SSH session in the cloud. And so now we get this, the session is saying, this is going to make some calls on your behalf to the Google Cloud APIs. And so I'm going to allow it to do that. So it's cloning that Git repo that we were just looking at. And now it's asking me, do I want to deploy this to the JW demo project? On Google Cloud, we can organize things into projects. And so I have a project here, JW demo. And so, yep, that's the project that I want to use. And then it's going to ask me, what region do I want to deploy into? And I'm going to say US Central 1 sounds good. And now it's going to take the source code for that application, which we'll look at in a second, and it's going to build it into a container image. So a container image is kind of like a zip file that just has everything that's needed to run this application. And so this has the operating system, it has the JVM, and it has, of course, our application that we're building now. So we're doing this with a tool called Pack, and Pack is from the Cloud Native Buildpacks project. And Pack knows how to build lots of different types of projects. It knows how to build Maven and Gradle projects. It knows how to build Go projects. It knows how to build Node projects, Python, all sorts of different stuff. And so we can run this Pack build on lots of different repos, and the build packs just figure out how to turn the source code that we're giving it into a container image, that zip file that contains everything that's needed to run our application. And so then we give it the coordinates for where to store that container image. I'm telling it to store up on the Google Container Registry in my project, and then I'm giving it a name for that container image. And then I give it the path to build because we were in a subdirectory of that Git repo. And then I tell it the build packs that I want to use. I'm using the Google Cloud build packs, but you could also use the Heroku build packs or the Paketo build packs or other build packs as well. Build packs are just a collection of things that know how to build different types of projects. And so Google Cloud has their build packs, and So, okay, so that container image is building. So this is a from scratch build. So it's got to do everything. It's got to pull down, in this case, Gradle to build the project. It's got to then do the Gradle build. And then pull down all the dependencies and assemble everything into the final container image. So that's going to take a minute. So while that's running, let's go take a look at what's actually inside of this project, this gRPC Hello World streaming project. So this is using gRPC, and I want to give a little bit of background on gRPC. We actually just yesterday announced gRPC Kotlin 1.0, and so you can read the blog post on the Google Developers blog with more details about that. But let's to talk about gRPC, let's actually pull up IntelliJ IDEA and walk through what's actually going on in this project. So I'm going to start out here by showing you the proto file. So the proto file is protobuf, and protobuf is a language agnostic way to define essentially the data classes that we're going to use, or POJOs, and then the services around those. And so in this particular proto file, what we have is we have a service, and our service describes our RPC endpoints to interact between a client and a server, a gRPC client and server. So I've got an RPC called say hello stream, and the parameter that it takes is a hello request. You'll see down here below is defined a message hello request, which has a string name, and then there's this =1 here. The =1 is just telling it the order in the serialized format, and by specifying this number, it allows us to evolve a protocol without breaking backwards compatibility. So if we come in here and later add in a second field, we'd say that second, we can say like int foo, integer foo, something like that, equals to enter integer. I forget which one. Luckily, we've got an IDE to tell us when we're wrong. Maybe there's some other numeric type. So we can specify a second field that allows us to add fields to the protocol without breaking backwards compatibility. Okay, so we take our hello request, and then we return. In this case, I wanted to do a streaming example, so we're returning a stream of hello reply. And so you'll see our hello reply has a string message, and again, that's the first field. So really simple example here. But this is now language agnostic, so we need to have some way to generate the client and servers for this proto and the message serializers and deserializers. And so that's where gRPC Kotlin comes in. And so here in my build Gradle KTS file, here's where I bring in that. And so I've got a Gradle plugin that's going to use the Google protobuf plugin, and then we're going to use that down here. So here's where we set up our protobuf plugin, where I'm going to say, all right, we're going to use a tool called proto-C, the proto compiler, and we're going to set up some plugins for proto-C. So first, I have the gRPC plugin for proto-C, and this will generate the gRPC pieces. We could just use protobufs and the proto-C compiler just to generate the stubs to be able to read and write in multiple languages if we want those protobufs, the way to interact with protobufs. But gRPC adds the ability to do the services, the RPC services, on top of protobufs. And so that's why I'm adding the gRPC plugin here. And I'm actually just using the Java gRPC plugin. So that's going to generate Java files. But then I'm also adding another plugin, which is gRPC KT. This is the gRPC Kotlin piece. And this is the piece that's going to generate the Kotlin wrappers that give us idiomatic Kotlin on top of gRPC Java and on top of the generated Java protobufs as well. So gRPC Kotlin today sits on top of gRPC Java and protobuf Java. Okay, so we just set up that, and that's going to do the code generation for us. So that's, and then we've got a dependency here on our gRPC Kotlin stub, and of course we're using coroutines, and so we add a dependency on that as well. Okay, so let's go look at our server here. So we've got a very simple server. In my server, what I'm doing is I have to give it the implementation. So gRPC is just going to give us the stubs that we need based on our proto file. So that service that's defined here, our greeter, say hello stream. But we have to actually give it the actual logic. And so what I'm going to do is I'm going to say, all right, we've got this gRPC greeter, gRPC KT, file that was generated. And we can actually pull up this generated file and see what that looks like. And I want to show you actually where it lives in our project. So I've already run the build, and so it's already generated it. But you'll see in my build, generated source proto main, and then we get our three plugins for our three proto C plugins. So we get our GRPC plugin, our GRPC KT plugin, and our Java plugin. So our Java plugin has those Java wrappers around the data objects, the data transfer objects there, hello reply and hello request. And then we get our Java generated GRPC RPC stubs. So this is the greeter implementation, greeter stub, those kinds of things. But then we get the one that we're looking at, our greeter coroutine impl base that we're going to use, and that's generated from GRPC Kotlin. So here you can see the implementation for all that, but that doesn't matter so much. What's more interesting is our implementation that's actually going to do something. So we have a function, say hello stream, that takes in a request parameter. That's our hello request. So you'll see that I have a hello request object that was generated from that proto-C, from that protobuf file. And then what I return in this function is a flow of hello reply. So this is using the Kotlin Flow API, which gives us a non-blocking cold stream. And so now I can create a stream for my server. So I'm just going to have a stream that is going to, every 1 second, create a hello reply message and emit that onto the stream. And so I'm delaying 1 second, and this is going to run in a loop. And then I'm going to emit a hello reply. So I'm now assembling my hello reply, setting the message, and calling build on that. And so that's my server implementation. And then I start up my server and my main method. So that's kind of all there is on the server side. Let's go take a look at the client side here. So I've got my hello world client. And now, just like on the server, we have some stubs that we need to implement. So I'm going to, in this case, I need to set up my channel to communicate with the server. So that's this managed channel. And then I am going to do this run blocking. And the reason why we do a run blocking is that when I interact with the Flow API, what I actually get back on this say hello stream or actually when I do a collect on the stream, when I actually do an interaction on the stream, it's actually a suspend function. And so this is now in Kotlin Coroutines. And because I'm in this case with my client, I don't need to have this method be a suspend fun. I'm just going to do this run blocking. So I'm just going to run this coroutine stuff in this blocking call. Okay, so you'll see that I'm assembling my request, and then I call my GRPC stub. I call the say hello stream on it, give it my request. And so what I get back from that is my flow, which is a flow of hello reply. So all this stuff has been generated, all the kind of stub code has been generated for me, and then I just provide my client implementation where I call flow.collect. So on every message that comes in on that stream, I'm just going to print that out. So really basic. And then in my main method is where I set up a connection to my server and then actually call that greet method. And I needed to set up some coroutine stuff there. Okay, so that is my whole client and server, gRPC client and server. One of the nice things about gRPC is that we can use any language for clients and servers. So I'm using Kotlin for both the client and the server here, but if you want to, you could have a Node client that's talking to our Kotlin server, and gRPC just handles all that stuff transparently for us. Okay, so that's my client and server. Let's go check back here on my deployment here in Cloud Shell, and it looks like great, everything has been deployed. So let's we see that the pack build completed, and our container was stored up in the cloud on the Google Container Registry, and then we did a Docker push to actually store it up in the container registry, and then we can use gcloud run deploy to actually deploy this service up on the cloud. So I give it a service name, so that's this gRPC Hello World streaming. I tell it my project, tell it that I'm going to use the managed platform. We can also use a platform based on Kubernetes, which is called Cloud Run for Anthos. And so we want to use the fully managed serverless one. So that's what the managed is. We give it the region, we give it the image that we're going to run on the cloud, and then we're telling it to allow an authenticated request. Okay, so my application is now running up on the cloud, but we need to actually run my gRPC client against that thing. And so If we look in the README for this project, then we can go and set up a few things and actually run the client. So let's paste this in here. I need to set up my project ID, and then we can now run. So in my Docker container that was assembled and deployed on Cloud Run, I actually have two processes that I can run in there, and I'll show you how that works. There's this proc file, and the proc file gives us two different commands that we can run. One is my server and one is my client. So that's what we're going to actually do is when I run on Cloud Run, I'm running the web process, and now from Cloud Shell, I'm going to run the client process to be able to make those calls up to my server. So let's just copy it up to there and paste this into Cloud Shell. And now I need to give it the endpoint to connect to, which is going to be my Cloud Run service. So this is the URL that was created. I can, of course, give it custom URLs if I want. So I'm going to give it that URL and close my quote there. And so now this is going to use that Docker container, and it's going to run the Hello World client KT and give it the server to connect to. And so now you'll see that it's starting up because Cloud Run is serverless. So initially there were not any servers running behind this. And so it took a second for it to spin up that first server. But now you'll see, sure enough, once a second, we are consuming that stream of events coming from the server and just printing them there. Okay, so great, it all worked. We've got our client and server all working. Now we can go and explore some other things about Cloud Run. So Cloud Run runs your containers, your Docker containers on the cloud, and it does so serverlessly. So that means it's a managed service, so you don't have to think about managing the servers underneath this. And we can see a few of the things around Cloud Run. So when we come into this service, we can see some dashboards around request counts, latencies, billable container instance time. So with Cloud Run, you only get billed when you're actually using the service. So when a request is being handled. And Cloud Run is unique versus some of the other serverless options because a container can handle, or a container instance running on Cloud Run can handle multiple concurrent requests. You can now go up to 250 concurrent requests on Cloud Run. And so what that means is that when you have overlapping requests, so if I've got 100 requests all coming in at the same time, I'm only paying for one container instance if I've set the threshold for concurrent connections above that given 100. So we've got our billable container instance time and then memory utilization as well. Okay. So there's nice metrics. We can see my revisions. So you can see that I have deployed this given service a number of times. So we can at any time change the routing between different revisions. So I can actually say, all right, if I'm rolling out a new version, I may want to only route 10% of my traffic to the new version, and then gradually roll that up to 100%. So you can do that traffic splitting here with managing the traffic to your different revisions. You can, of course, roll back that way too. We can come in and see the logs for our application, and those will load in a second here. Not very exciting in this case. We just see the server starting up on the JVM, and then you'll see actually, hey, the server shut down. So we weren't getting any more requests, and so Cloud Run just shut that server down at some point. And so you'll see it starting up and shutting down based on the demand to the application. So the more requests we get, then the more instances that are going to be needed, and that's configured through our concurrency settings. So if we go to, let's see, if we go to a given revision, then we can see some information about this given revision. We can see the container image that was deployed, the port that it's listening on, the command, the service account, memory allocated, CPU allocated, concurrency. The default is 80, so that's what that is. Request timeout, max number of instances to scale up to is 1,000, and any environment variables, SQL connections, VPC connections, that sort of thing. So from this UI, we can also go in and deploy a new revision of this application. So we can come in and select our container image that we want to deploy, set any settings, and then deploy a new instance of that. You also see there's this new feature that we just added that is to set the minimum number of instances. So if you don't want to have what's called cold starts, then you can crank up the number of minimum instances as well. And in that case, you are not necessarily necessarily paying based purely on demand to the application. You do, if you allocate minimum instances that are just sitting there possibly idle, then you do pay for those. But if you're running it with 0, then you scale down to 0, and then you only pay for exactly the usage of the service. There is a free tier of usage on Cloud Run as well. So if you want to get started then and just do some simple playing around, then you don't have to pay anything, which is nice until you go over the free tier usage. Okay, and then also from this UI, you can set up continuous deployment of this application, which is certainly a good idea for anything real. I've just showed you the easy, quick way to deploy the application manually, but for real stuff, you want to set up continuous deployment, and you can hook this to GitHub or other source control systems as well. And that will just automatically deploy new revisions once they've been committed to the master branch. Okay, so that's our quick overview of running a Kotlin gRPC service on Cloud Run. Antoine, any questions so far?
Yeah, could you probably clarify it a little bit? There is a question of from Roman. He asks, like, who actually takes care of building the container? So it probably was a little bit too magical and fast-paced.
It was too magical. That's exactly right. Yeah. So in this case, when I did that Cloud Run button, what happened was Cloud Run button said, oh, Cloud Run button knows how to build things in a couple different ways. And it looked for a Docker file. There was no Docker file in this repo. And so what it said was, okay, I'm going to try to use the cloud native Buildpacks to build this thing for us. So it used Buildpacks pack build to build the source code that was cloned when we ran Cloud Run button to build it into a container image. You could also use a Docker file. You could also use a tool called Jib or other ways to create your container image. So Buildpacks, they can be the magical, transparent way to build your source code into container images. But if you want more flexibility, then you can use Docker files or other methods as well.
So if I use the build pack, it means that there is a convention, and if my application follows the convention, then it kind of fits into the build, right?
That's right. Yeah. And so so as an example, the Google Cloud Buildpacks don't yet have support for something called GraalVM, which we're going to look at in a few minutes. And so when I've used GraalVM, I have not used the Google Cloud Buildpacks. Instead, I used a Docker file. And I think that I actually have an example of that in the GRPC Kotlin repo. So in the GRPC Kotlin repo, let's go see if I've got a Docker file in here. So there's some examples in here, and there is a client, and the client won't actually have that. Let's go look at I've been working on doing a GRPC Kotlin GraalVM server. Oh, and I don't have the Docker file in there yet. Okay, I will find you a repo where I do have a Docker file for this. So in my repos on GitHub, if we go to search for comparing, okay, I've got this comparing Docker methods repo here. And if we go to the GraalVM branch, then we will see my Docker file, which is using the GraalVM base image, and then is doing the building of my application, building of the GraalVM native image. So lots of stuff there. But then this actually results in a super tiny container image that that only contains a single executable. So I have a talk called Comparing Docker Methods, and check out that if you're interested in exploring that more. But yes, you are responsible for creating the container image. Cloud Run does try to make that easy with Buildpacks. So if you don't want to think about it, then just pick Buildpacks and you're good to go. One place where you actually see that is when you go into set up continuous deployment for a repo, you'll get to a place where it's going to ask you, how do you want to build this thing? And you can choose Dockerfile or Buildpacks in there. And then there's a couple command line ways as well to build things with Buildpacks.
It seems that Buildpack is something really interesting for the people. Like, could you explain a little bit more? How do I know that it's going to build with the Buildpack? And what should I do? Like, what should I definitely know to actually smoothly use this tool?
Yeah, Yeah, so you'll see that in this particular repo for this one, and I think everything that I'm going to show you today is Buildpack compatible. But the key here is that I have in my build said that I want to have an application, and what happens is that the Buildpacks actually they do a Gradle install or something like that is the task, and we could go look and see what exactly the task that runs is, and then it takes the dependencies and my application and puts those into the container image. I do have a example that uses Maven as well, and so certainly Maven is supported. If we go back to Kotlin samples run and look at like the Maven example, this is a GRPC Maven example, but the key is that we have something that is runnable. Our build outputs something that is runnable. So in most cases, the build packs should be able to figure out how to run this thing. And so in this case, we're using the exec Maven plugin, and we're using the Maven dependency plugin to set up the ability for build packs to be able to get the dependencies and be able to exec the main process there. So yeah, so it's usually pretty straightforward to be able to have build packs be able to take your source code and turn it into a container image. There are always going to be little corner cases, and so in those cases, maybe you have to drop down to using a Docker file, something more flexible. But my default is to start with build packs, and if it works for my use case, then great.
Is there a resource where people could learn about build packs? What is supported? What are the other options that are supported by this tool, and so on?
Yeah, so buildpacks.io is the main site for the cloud native build packs. But then if you search for the Google Cloud build packs, then you'll get to the build packs that I am using. And those are, let's see, Google Cloud build packs somewhere on GitHub. Here we go. GitHub, Google Cloud Platform build packs. And this is where the information about the Google Cloud build packs are. But you can use any build packs you want. You could use the Heroku build packs. You could use the Paketo build packs or other build packs. And so the documentation for the Google Cloud build packs is here. It's one of the things that is a little weird in the build pack world is that you pick your build packs, and different build packs have different capabilities. So for instance, the Paketo build packs actually support GraalVM out of the box, whereas the Google Cloud build packs don't. So I'm using the Google Cloud build packs because why not? But you can of course use any build packs you want. With Cloud Run, you just give us a container image. We don't care how that container image was created. You can create it with any tool you want. We just need a container image. So yeah, you can use build packs, you can use Docker files, whatever.
Perfect.
Okay, so let's, we've gone through the management UI for Cloud Run. I do want to show you the container registry so you can see how that looks. So this is the interface for where I actually stored up my container image, and we did the GRPC Hello World streaming. So you can see in here that I've got a container image that was just uploaded 20 minutes ago, and it has a tag of latest on it. So this is just something that is Docker registry compliant for storing these container images up. So if you want to, you could pull this image down. This will show you the pull command to pull it down to your local machine or somewhere. We can deploy this on Cloud Run, which we already did. Because it's just a container image, we can run it also on Kubernetes or on Google's managed Kubernetes service, GKE, or we can run it on a raw GCE, just a compute instance as well. So anywhere that can run containers can run those container images. So I'm showing you Cloud Run because that's the nice, simple serverless example. But I know a lot of people use Kubernetes. And so, of course, you could take everything that I've done here, and instead of doing gcloud run deploy, run it on your Kubernetes as well. Okay, so that is our quick and easy deployment, gRPC Kotlin, running on Cloud Run. But let's go on to a couple other examples. So in this Kotlin samples repo and then in Run, there's a couple other ones that I want to walk through. So there's, we're going to go on to Ktor next. So Ktor is a Kotlin first framework that you can use to build server and client applications. And so I want to just walk you through a quick little example. And of course, you can do the, if you go into Ktor Hello World, there is of course a button to deploy that and instructions for manually deploying that up on Google Cloud and Cloud Run as well. But let's walk through it so you can see what's in here. I've got a dependency on Ktor server, core, and then I'm using CIO, which is like the native Ktor networking library. You could also use Netty or I think other ones as well. So pretty simple dependency definition. I've got a main class. This main class is how Buildpacks now know how to run this thing when I do this with Buildpacks. And then let's take a look at the actual code for this thing. So one of the things I like about Ktor is that the API for building services and building clients is Kotlin idiomatic. And so I get this nice functional way of defining my server. And so I'm installing my default headers, installing my call logging, installing my routing, and then I set up a route for / that's going to respond with just text, in this case, hello world. So, and let's see, this one is a suspend fun. So this is also using Kotlin coroutines. So coroutine support, great. So you'll see the main method where I embed my server and start it up. So really simple. You can deploy that and play with that one. I've used Ktor on a number of applications. One of the nice things about it is that because it has support for Kotlin multi-platform, I can use the Ktor stuff in lots of different places and only have one programming model for doing client and server interaction. So, I've really enjoyed my experience with Ktor. Encourage you to check out that option. Okay, let's go on to the next one, which is, I'm not going to deploy that one. You can have that as homework. I'm going to do this Micronaut Hello World. Micronaut is a framework that supports Java, Groovy, and Kotlin. And so I want to show you how Micronaut looks. So you'll see that I'm just adding some dependencies for Micronaut. I'm using the Netty HTTP server. And then Micronaut uses annotations to wire together the application. So if you are a Spring Boot or Java EE developer, then these annotations should feel very familiar to you. The one unique thing that that Micronaut has done that's pretty nice is they're not using these annotations for reflection. Instead, they're actually doing a Kotlin annotation compiler that is actually using those annotations to do compile time wiring of the application. And so I've really enjoyed that experience in Micronaut and used this on a number of applications to wire together an application with annotations. Micronaut has support for Kotlin coroutines. And so you'll see this particular example just trivially uses coroutines. But definitely enjoyed using Micronaut. If you're coming from the annotation-based world, then Micronaut is a great option to explore. Okay, next one I want to talk about is Quarkus. Quarkus, in this one I'm using Maven for the build, so you can see the Maven build information there. Quarkus has the advantage of still using annotations for defining the wiring of the application, but it uses the standard Java EE annotations and the Java Web Service annotations for its annotations, whereas Micronaut uses its own annotations. So still annotation based. So one of the nice things about both Micronaut and Quarkus is that they've done a lot of work to have support for GraalVM, which we're going to get into in a few minutes. So that's one of the interesting things. As far as I know today, Micronaut definitely supports coroutines. Quarkus, as far as I know, does not yet support coroutines. So that's one of the reasons why I've reached for Micronaut more often than Quarkus is the coroutine support there. But I think that they're working on the coroutine support in Quarkus, or maybe already have it. So, anyways, lots of great options there for building server-side Kotlin applications. And of course, these all run on Google Cloud. You just create your container images however you want, or do it with Buildpacks if you don't care, and get them running on Cloud Run or Kubernetes or wherever. Okay, so now let's go on to the next example here, which is a Spring Boot example. So the Spring team has done a decent amount of work to support Kotlin and make that support seem nice and first class. So obviously still annotation based for wiring the application together. But I want to actually do a little bit of work on this application just so you can see what things actually work. And then we're going to go into some more details on reactive and some of that stuff. So I'm going to start this application up just in IntelliJ. I'm going to run the Gradle builds and get this thing up and running. You'll see that I'm running two Gradle tasks. One is a continuous compile of the classes, and then the other one is actually running the Spring Boot application. So let's go check this thing out in the browser. So here we go. Let's reload this, make sure it works. Great, we see to do. Okay, so now let's actually build a Kotlin Spring Boot application. And my use case for this is that I always have a hard time finding what the latest version of Kotlin is. And so we can find this out by going to the GitHub API and just pulling the tags for the Kotlin repo. And you'll see I get some nice JSON here, an array, and then object with a name and the latest version, 1.4.21, which I think is brand new. So what we're going to do is we're going to consume this service in Spring Boot and get the latest version. Okay, so you'll see that I'm in a Git mapping for / I've got a suspend fun, so I'm in coroutine, something that can handle coroutines. So let's now create a value to hold my URL. So one of the nice things if you're new to Kotlin is type inference. So you're seeing that I didn't have to specify the type on this thing. The compiler just does that for me, infers it for me. Of course, I can explicitly put it in there if I want to. Okay, so now let's use the Spring Web Client to talk to this service. So I'm going to, before we do that, I'm going to define a data class. And data classes are one of the really nice features of Kotlin where I can just say, all right, let's define a release. And a release has a property, which is a name. Okay, and that's going to model the thing coming back from GitHub here with just the name on it. So I didn't have to set up getters and setters. I didn't have to create constructors. The data class syntax just super nice and just gives me a lot of features for data transfer objects and classes. Just super easy. Okay, so what I'm going to get back when I call my service is going to be my releases. So we'll type that in there. And then I'm going to use my Spring Web Client. Web Client is reactive. So this means that we're using reactive IO. So we're not blocking threads when we're not actually operating on transferring bits. And so that's a nice thing. Spring Boot has made sure that this stuff works great with Kotlin coroutines. So I'm going to call get on web client. So I'm going to make a HTTP GET request. I'm going to give it the URL that I'm going to call. And then I'm going to tell this thing that, all right, let's retrieve the response. And retrieve is, let's see, is that my, okay, so retrieve so far is just retrieving a response. But what we need to do is get this response into our list of release. And so I'm going to call this await body. And await body is an extension method that's on that response object. So a Kotlin extension method, another nice feature of Kotlin. And you'll see that await body is a suspend fun. So this is a coroutine. And so what I'm going to say is I want to deserialize this, this response into a list of release. Okay, so that await body is a coroutine, a suspend fun. But now, because coroutines are awesome, what we can do is now we can just take our releases and operate on them as if they're right here, when in fact, this all behind the covers is being turned into non-blocking calls and coroutines, that kind of stuff. Okay, so we've got our releases. What I want to do is I want to first do a filter on this list because in this list, there are things that are not actual like final releases. There are things that are pre-releases and that sort of thing. And the real easy way to know if something is a pre-release is to say, does the name contain a dash. Okay, so we're going to first filter out everything that contains a dash. And another nice feature of Kotlin here is this lambda syntax, where I can just call this it instead of having to specify the parameter. Of course, we could do this the longer way, where we say R, and then we put in the syntax here. And so we could, of course, do it that way with the more literal full syntax for creating a function, or we can do the nice short syntax there. Okay, so I've filtered my list. Now what I want to do is get the first or null item out of this list. And I'm saying or null because if this list is empty for some reason, and I call .first, then I'm going to get an exception, because it's going to be like, hey, element not found or whatever. Okay, now what I want to return is the name, but you'll see that when I do this, it's like, hey, you can't call .name on this thing because Kotlin has support for nullability built into the language. And so what I need to do is do a syntax here with a question mark to say, all right, when this thing is not null, then get the name. But what I get back out of this is something that is nullable, and so and type safely nullable. And so what I want to do is actually be able to handle that case and say, all right, if it was null, if this chain of operations was just null, null, null all the way through, then what I'm going to do is provide a default, and I do that with a question mark colon, and then I can say not found. And then let's save this thing. And what's going to happen is now it's going to recompile that and restart my Spring Boot application. And then it's going to go call that GitHub API, and it's going to get that list of releases, do the filter, and we see, yay, we have the latest release, 1.4.21. Okay, but let's see what would happen in the case where that list actually is null. So if we go back to our code and I give it a repo that does not have releases, like my James Ward Kotlin repo, and go back here, then that first or null would have been null, and that question mark gave us that type safety around that nullability. We didn't have to do the if null thing, which we probably would have forgotten to do, and then we would have got the runtime exception, null pointer exception. So it made us, Kotlin makes it really easy to think and deal with nullability. And so sure enough, great, it works, not found. Okay, so we've got our application here, and let's go back to our JetBrains repo. We know it's working, and now I'm going to deploy this thing up on Cloud Run so we can see how that works. Okay, I've got my my whole project. It's all good. What I'm going to do is now let's first build this thing into a container image. Spring Boot now has support for doing building container images just built into Spring Boot. So the way that we do that is we run our build tool and call boot build image. Of course, you can do that from Maven or Gradle, and we give it the image name that we're going to, the coordinates for where to store that container image. So underneath the covers, this is actually using Buildpacks. So it's actually using, in this case, the Paketo Buildpacks. We could use different Buildpacks, but the default is the Paketo Buildpacks. And those Paketo Buildpacks say, hey, I know how to build a Spring Boot application. And so there we go. It built it. You'll see it happen super quick because there was some stuff that was cached, which was nice. But now that we have our built container image, let's go do a Docker push that container image up to the Google Container Registry. One of the really nice things about Docker is that it has layers in images, and this allows for really great caching support. So you'll see that when I went to go push this thing, it's like, hey, I already have all these layers. You don't need to re-upload those. So great. So that happens super fast too. And then what we can do is actually deploy this thing on Cloud Run. I'm going to do this gcloud run deploy, just like Cloud Run button did for us. But I'm now doing it manually from the command line here. So now it's taking that container image that's stored up on the Google Container Registry, deploying that to a service on Cloud Run. The name of that service is Spring Boot Kotlin Reactive Demo. Okay, so that's now getting the new revision created, and then we will be able to go and check out our application running on the cloud.
And the folks are really impressed with the speed. of the attack?
Well, there is some caching going on here, so making it nice and fast.
Right.
Caching is great. It's nice when we have things that support good caching. So let's go load our application. Okay, so this application is going to take a second to load because there weren't any instances running this application because Cloud Run is serverless. So it's now got to go get the container image, start up the process, and then make the request out to that GitHub API. So let's go over to the Google Cloud Console and go actually see what's happening here. Let's go to Cloud Run, and we'll go get to our service that we are working on here, which is the Spring Boot Kotlin reactive demo is the one that we just deployed. If we go to revisions, we'll see that, yep, that one was deployed 1 minute ago. We can pull up the logs and see the startup. Okay, so you'll see that, that if we go to the latest one, it looks like it took, the JVM was running for 5.5 seconds is how long it took for that to start. Okay, so that's cool. Our application is working. We got the latest release. It's running on the cloud. We got HTTPS, all that good stuff. But let's see if we can make this thing a little bit better. So there is this thing called GraalVM, which allows us to create ahead of time compiled native images for our applications. And I've mentioned this a number of times that you can do this with Micronaut, you can do this with Quarkus, you can do this with Ktor, and I'm working on being able to do it with the GRPC server. You can do it with the GRPC client today, and I have the example of that. But Spring Boot just added support, good support for GraalVM as well. And so I'm going to just blow away everything I've done and check out a branch here because there are a few changes that I had to make to get this thing all working. So one of the challenges of doing these GraalVM ahead of time compiled native images, meaning they run not in the JVM, it's taking these JVM-based applications and turning them into ahead of time compiled native binaries. And so one of the challenges to doing this is that there are some JVM features that are hard to do ahead of time. Reflection is one of them. And so with reflection in GraalVM native images, you have to explicitly tell it about the reflection that's happening, and so that GraalVM can know how to handle that. Okay, so I've switched over to another branch of code here for GraalVM, and I've changed a few things about this application to make it work a little better with GraalVM. So one is that I've switched from normal Spring Boot and the annotations to a project that is called Kofu. That's for Kotlin or something, and this adds a DSL, which is pretty nice for writing our application. So you'll see that this application is doing the same thing that we were doing before. I've got my method that is getting the latest release. I've got my application, but you'll see I've got my release, but you'll see that I am defining this application not with annotations. I'm not wiring it with annotations. I'm instead using this nice Kotlin DSL, very similar to the way that Ktor does things. And so this is going to end up being a little bit more friendly to GraalVM because I want to try to limit the places where I do reflection, just because then I have to explicitly configure them, and sometimes there are challenges to reflection. You'll see that I went even as far as manually doing my JSON deserialization, and that's just because I had some challenges with the reflection in GraalVM, and I need to keep working on that and figure out how to get that working. I'm sure that it can work, but anyways, I just went with manual, no reflection-based JSON parsing to get this working. Okay, so same application here, but this time with Kofu and GraalVM. Okay, so I've got my application, and now let's go run build this thing into a container image. So when I build this thing into a container image this time, I'm just going to specify this pnative flag, and this is because of some build stuff that I've done in the Gradle build. It allows me to do the native build for GraalVM instead of the jar-based build and JVM-based build. Okay, so I'm going to run this, and it actually takes a decent amount of CPU to ahead of time compile a Java application into a native image. And so, Antoine, if I cut out for a second, don't worry, I will be back. It's just that my CPU has exploded or something like that momentarily. Okay, so you'll see that this is now, again, using Buildpacks because the Paketo Buildpacks have support for GraalVM. And so it's using the Buildpacks now to build this container image, but do the ahead of time compilation on this application. So questions while this is building?
Yes, there are a few questions basically about the same stuff. How long does the instance stay alive after the last HTTP call? Is there a default, or can we configure that or anything like that?
So it stays alive for some amount of time. I don't remember what that time is. It's like a minute or two. I don't think that today on Cloud Run fully managed, it's configurable. If you're using Cloud Run for Anthos, which is based on an open source project called Knative, then you can configure, you can tweak all the knobs in those cases. And so, yeah, I don't remember, it's in the documentation for Cloud Run what the default kind of keep alive time is, but I don't think today it's actually configurable. You would have to use Cloud, at least it's not configurable in the managed serverless Cloud Run. You can do it in the Cloud Run for Anthos on GKE or Knative.
Right. There was an interesting question about Kotlin native, actually. If we can skip the JVM, create a service using Kotlin native, and just run it in Google Cloud, in Google RAM. Have you tried that yourself?
I've not tried that, and I need to, because I think that we could use Kotlin native with Ktor. And so it should be totally possible to create a native executable, put it into a container image, and run that on Cloud Run. Cloud Run just takes your container image. So however you want to create that is fine. So should be totally possible to do that, and I will work on a sample application that'll show that.
I know it's possible to create an HTTP service with Kotlin native, but Ktor itself is not ready for that yet.
Okay.
I think it's going to support that soon, like in the next few releases. The plans were to support native on the server side. Currently, Ktor is multi-platform for the client side. Like
just for the client side. Okay.
Yeah, it works for JVM, for JavaScript, and for native as well, because they want to use it in Android and iOS development. It's pretty popular there.
Awesome. Yeah, so you'll see that the build is still running here because it's having to take all of the code paths and ahead of time compile them into native non-JVM based code. So it's probably just about done. But one of the nice things is that this is going to start up a lot faster and actually use less memory than it would when we're running on the JVM. So that works well in serverless environments where I need things to be more elastic, and it's great if it uses less memory as well. And we'll get this thing deployed up on the cloud and see it start up super fast.
While it's finishing, there was also a question about monitoring. I think it's a good one. Since we're using Google Run, right? The Google Cloud Platform.
Yep.
I think the stack driver is the default choice, or can we use something like Prometheus because we are running the containers?
Yep. Yeah. So you're right that on Google Cloud with Cloud Run, the default metrics and stuff go into Stackdriver, but you could, of course, use whatever log collection, metric collection stuff that you want. So yeah, totally configurable. Up to you how you want to do that.
Great stuff.
Okay, my now GraalVM container image is now built. Let's go do our Docker push of that thing and push it. You'll see that my layers are cached except for this 70 meg layer that was my my Spring Boot application compiled into that native binary. So it's now pushed that up to the container registry. And now let's go do a new deploy of our application here up to Cloud Run. So just taking that new container image and getting that up and running on Cloud Run. And if we go back to our console, we'll keep watching these logs here and see when this thing, how much time it takes to start up. And that's really the exciting thing that we're looking for. Let's go make another request. And so the cold start time should now be quite a bit faster on this one. So let's see if we can see that startup time. There we go. So now with this case, with the GraalVM, one, we started up in 0.4 seconds for the startup and 1 second JVM time. So that was 5 times faster. So not bad for doing that. Oh, and it looks like the second time started up even faster as another request came in for some reason. Maybe something was a little warmed up or something there. But so I think that GraalVM is a nice option for places where we want to optimize memory, startup time, that sort of thing. One of the questions that I often get about GraalVM is that took a long time to build that ahead of time compiled native image. And yes, it does. What I do when I use GraalVM for applications that I run in production is that I actually will do this as just part of my CI/CD pipeline. So I don't do this as a developer like I just did here. I really just put that into my CI/CD pipeline. Quarkus, one of the nice things about it is it actually has a way to run tests against the native image. Because we're not running, what I do as a developer is I'm running on the JVM, but then if we're running in production in a GraalVM produced container image, then that's different. And there could be things that potentially don't work the same. And so it's nice to be able to validate that our native image works as we expect it to. And so that's where Quarkus has some really nice support for testing the native image as part of your CI/CD process is where I'd put that.
Have you compared the resulting image size, like the one for JVM and the other one for GraalVM? Like, does it differ?
Yeah, it definitely does, because we don't need the JVM when we're doing GraalVM, so that reduces quite a bit. In this case, I think that the layer that was created with my native image was like that 70 megs, so still pretty large. And I think that's because, like with Spring, there's a lot of dependencies and stuff that's going on there. Whereas in my talk on comparing Docker methods, I go more into the actual container sizes, and I now have a container image that has a Java GraalVM compiled application that is 3.5 megabytes for the whole container image. And so that's your minimum. As you, of course, add more dependencies and things, then it's going to go up from there. But I think that we could actually get this Spring Boot example, the whole container image, down quite a bit more than what it is now. Let me see if I have Dive installed, because you can actually use this this tool called Dive here to go explore the container image. It's a fun little tool for seeing what's actually in these things. So here's the Dive interface. You'll see that our total container image for the GraalVM one is 90 megs. So that's pretty good. With the largest layer, these are the different layers of the container image. The largest layer, 70 megs, being probably just that compiled native image binary, which I'm sure we could get down quite a bit more than that if we wanted to. Mm-hmm. But the base operating system, 18 megs, that's pretty nice. So yeah, that's it. Okay, so we saw the GraalVM version of this application up and running on Google Cloud Run. It's just a container image. You can run it anywhere that you run container images. So the portability of that is really nice. But if you want to get started with any of these, then go check out the examples on the Google Cloud Platform, GitHub, and then Kotlin samples. And then these are all in the run directory. And I think that I have a GraalVM version of at least the Micronaut and Quarkus one, because they've got great support for GraalVM. And I should add the Spring Boot one as well. Okay, so one quick plug is if you're doing Kotlin on Google Cloud and with Spring Boot, I know a lot of people are doing now doing Kotlin and Spring Boot together. There is check out the Google Cloud Spring Boot. Let's see. So there is a whole project to support Spring on Google Cloud, and there's actually the next in the series of these Tech Talks is going to be going into a lot more detail on using the Spring Cloud GCP stuff. So if you're interested in the Spring on GCP stuff specifically, check out that next talk. Okay. That was a lot, and hopefully there's some questions. We have a few minutes left.
Oh yes, there was one question coming just now. If the example that you are using could be using Hibernate for automatic transactions management, I guess it's not a problem. Maybe
Is that with
if you use if
GraalVM
you use
and
yeah.
Hibernate specifically? I think it's all technically possible. I think that sometimes the challenge is around configuring the reflection. What I would guess that because Hibernate is supported by the Red Hat folks who are the people that support Quarkus, that they are at least working on adding good GraalVM support for Hibernate because they've done such a good job of supporting GraalVM with Quarkus. So that would be my guess, but I haven't personally tried Hibernate with GraalVM.
I think in Quarkus they have Panache or something like this instead of Hibernate. And if we run the application in Cloud Run, does it even make sense to have Hibernate? It's actually stateful.
So you definitely can. You're going to lose some of the benefits of that cache that is in Hibernate, because whenever the instance goes away because it's not getting any requests, then you're going to lose that. But as long as that instance is kept around, then certainly you get the benefit of the cache, and you've got multiple concurrent requests coming in because Cloud Run supports concurrent requests, and so you're getting the benefit of that. As there's overlapping concurrent requests, then you're going to have that warm cache there for the application. So I wouldn't say that it's not at all useful. I would say that it may depend on your scenario and kind of how many requests you're getting. If you do want to make sure that you keep stuff warm, then just come in and set that min instances to 1 or whatever, and that will keep that instance around. So that's certainly an option for keeping things warm. But then, of course, then you're not paying based on pure demand, which is one of the benefits of serverless. But in some cases, it's worth it, and that's what you need to do.
Right. So yeah, there is no more questions, and we are right in time. And I think we can wrap it up here. Thank you, James. It was very insightful, very interesting, fast pacing. We had a lot of questions. People are still watching the stream, so that's a nice sign. And
Thanks for sticking with me.
for everybody, like we will have more webinars of Kotlin on the server side, and as I said in the beginning, we will have Raid Song in January. But we are actually working on more content, and we'll have more webinars coming soon. So stay tuned for the announcements, and have a nice evening, have a nice day, whatever the time of the day is where you are.
Awesome. Thanks so much, everybody, and thanks, Antoine, for having me.
Right. Bye.